can see the alternated layers of assets and actions. But here we can already derive some conclusions. For example, if we only have those exploits, we don't need to do a port scan and find all the open ports. Because if I have only exploits for the ports 21, 22, and 80, the information about the other ports, I won't use it for anything. So it's useless in terms of planning, and it generates more noise. And another thing that we can deduce is that we should start with port 80 because we have 2 exploits for that port and have better chances of succeeding. And as soon as I find an open port, launch the exploit. If it works, okay, finished. If not, continue with the next one. And so this is another example. So it's basically the same idea. I want to install an agent. Here I put an exploit for HD OpenView, a remote buffer overflow. And this one requires to know that the operating system is XBSD2 and to have a TCP connectivity with the port 5053. So that's where the service is listening. And to find the operating system, I have a choice of OS recognition modules. For example, one that uses banners, or one that uses stack fingerprinting. And to know if I have a TCP connectivity, so direct action, no, it's try to establish the connection. And the OS detection module that uses banners, well, it requires to have banners for a lot of different ports on that machine. And the one that does stack fingerprinting will require IP connectivity. And so like this, we start building this attack graph. And I don't know, what is your intuition about the problems that arise with this kind of idea? And basically, the problem that we have is that if you want to do an attack that involves a lot of steps, these graphs start growing exponentially. Because for one asset, you have a lot of different actions. All those actions have requirements. So this is, for example, a graph. This is a complete attack graph for a very small network. So you have like 10 machines, 10 exploits, and it already explodes. So if you want to go to a network with hundreds of machines and having hundreds of exploits, this really won't work. And so how did the story continue? What we have already presented with Alejandro Way in Impacted was a practical approach that is actually implemented in Impact, the Pentesting tool that our company does. And so it already does the automation, but the problem that it finds is with pivoting. It can't do pivoting. It can automate an attack, but with only one step. And it also doesn't optimize using information about the exploit. No? So it's like a kind of a brute force that launches exploit one after the other until it gets in the machine. And I've also presented in Frac an algorithm for probability planning. So in that work, I entered with the problem of dealing with the fact that the exploits are not completely, they are deterministic, but there are so many unknown values about the state of the memory of the target machine that in practice we can consider them as a probability. So when you launch an exploit, you're never really sure if it's going to work or not. And so this was like a more theoretical work where I worked on the demonstration of the algorithm and proving that having the right information actually gives you the optimal path. But this was still a research prototype. And so what I want to present today is something more practical. So we actually integrated a planner with impact with our Pentesting tool and analyzed a little bit the results of that solution. So what I really want to present now is the integration between the planner and impact. So this is basically what we have implemented. So here we have the Pentesting framework. So it can be impact or Metasploit. When you have all the exploits and all the modules are available. And then we have what we call the attack workspace, which is the information about the current pen test. So there you have the information about the network being attacked. And we have a transform algorithm to translate this into a PDL description. And in this description, you have the actions, which are basically the translation of all the exploits and modules that you have. And you have the initial conditions that make for the particular problem. And this is giving us input to the planner generates a plan, and then we execute the plan with the framework. So what is this PDDL? It stands for Planning Domain Definition Language, and we choose it because it's a language which was designed for the international planning competition, and so the good